Okay, so in this lesson, we're going to again be dealing with square roots, but we're going to be adding and subtracting. And then in part two, we're going to look at multiplication. But in part one, we're going to be adding and subtracting square roots. All right, so for example, if we look at number one, and the directions will either say something like add, subtract, or perform the indicated operations, or simplify. It could be one of all these. So simplify, perform the indicated operations, or I could say add, subtract. All right, so all of these could be the directions. All right, number one, we have the square root of 20 plus 2 square root of 45. All right, now, when adding square roots, when adding square roots, and again, we're only dealing with square roots, we're not looking at any other index in this particular lesson except square roots. So when adding square roots, let's talk about like terms. So remember that if I have 3x plus 5x, I can combine these because both terms have the variable x and the corresponding variable, in this case x, are both being raised to the first power. So 3x plus 5x is going to be 8x. Now these are not like terms. So as I had 3x plus 5x squared. Although both terms have the same variable, the variable x are both being raised to different powers, so they're not like terms. So you can't simplify. Can't simplify. So when talking about square roots, so let's talk about like terms. So these would be like terms. 5 square root of 3 plus 6 square root of 3. So we're talking about combining like terms with regards to square roots. The index has to be the same. In this case, they're both square root. They're both 2, so hence the word square root. Um, so in general, the index has to be the same, and the radicand has to be the same. So both of these both have the index 2 square root, and both of those have the radicand 3. All right, so it's kind of like the variable x. So 5x plus 6x is equal to 11x. So 5 square root of 3 plus 6 square root of 3 is going to equal 11 square root of 3. All right, now these would not be like terms. Something like 5 square root of 3 plus 6 square root of 2. So even though they're both square roots, even though the indices are the same, the indexes are the same, the radicands are different. So it's kind of like these being different variables. So you cannot combine these. So these, you would say, can't be simplified. Okay, so now let's talk about number one. All right, so first of all, they're both square roots, so these terms both have a square root, and we're only dealing with square roots. We're not dealing with cube roots, fourth roots, fifth roots, or anything of that nature. But the radicands are different. So you may say, well, you can't simplify this. Well, keep in mind, though, you want to simplify this as much as possible. So is the square root of 20 simplified? Is the square root of 45 simplified? So you got to simplify this. So the square root of 20, remember, is a square root of 4 times 5. And with this we get 2. And the square root of 45 is 9 times 5. Square root of 9 times 5. And remember, the square root of 4 is 2, so this becomes 2 square root of 5, plus the square root of 9 is 3, and 2 times 3 is 6, so I get 6 square root of 5. And now these are like terms. So now the radicands are the same. So 2 square root of 5 plus 6 square root of 5 is going to equal 8 square root of 5. All right, number 2. Okay, now let's talk about something else here. All right, so well, let's do number 2 first. Okay, suppose we had 4 square root of 32 minus a square root of 18 minus 2 square root of 128. All right, suppose I had that. All right, well, again, you're dealing with square roots. It's the only thing we're interested in here in this lesson. But 32, 18, and 128, although they're not perfect squares, there are perfect squares other than one that will go into 32, that will go in 18, that will divide into 128. So let's look at 32. So 32 we know is going to, so this term right here is going to be 4 times the square root of, and 32 we know is 16 times 2. 18, we know we can write this as a square root of 9 times 2. And notice the 2's here. So always look for things like that. So maybe all these three terms, you're going to end up with the square root of 2. So look at this and use that idea. Maybe it doesn't always work, but maybe it will this time. So 128 divided by 2 and see if we get a perfect square. So 128 divided by 2, you remember you're going to get 64. So 64 times 2. And so now the square root of 16, you simplify that. So that's going to be 4. This 4 times the square root of 16, which is 4, square root of 2, minus this is 3, square root of 2, minus, and then that's 2 times, and this right here, remember the square root of 9 is 3. So that's how we get this 3 right here. The square root of 64 is 8. I'm left with the square root of 2. Simplifying this, 4 times 4 is 16. So I get 16 square root of 2 minus 3 square root of 2 minus 16 square root of 2. And then combining like terms, 16 square root of 2 minus 3 square root of 2 is 13 square root of 2. And 13 square root of 2 minus 16 square root of 2 is a negative 3 square root of 2. So all you're doing is just adding the coefficients. So for example, all you're going to do is this. If you can't do this in your head, you're going to say 16 minus 3 minus 16 equal, and you get negative 3. So it becomes negative 3 square root of 2. All right, number 3. Suppose you had the square root of 16 minus 5 square root of 10 plus 7. All right, so the square root of 16, 16 is already a perfect square, so that's just going to be 4. So I get 4 minus, besides 1, there's no perfect square that goes into 10, so I get 5 square root of 10, and then plus 7. Combining like terms, the only terms I can combine here are the 4 and the 7, the constants. And so I get 11 minus 5 square root of 10. Now if you want to put this term first, the square root of 10 term, the term that has square root of 10 in it, you could say negative 5 square root of 10 plus 11. Either one is fine. Okay, number 4, suppose you had negative 2 square root of 50 minus the square root of 1. Let's see, I'm trying to think here. Those two, let's say 32 plus 5 square root of 72. Let's do that. Okay. All right, so that's 32. I guess I should change it from this one because this was a 32 as well. Let's change this to, let's say, square root of 200. All right. Okay, so 50 I can write as 25 times 2. 200 I can write as 100 times 2. And then plus 5 square root of, and then 72 I can write as 36 times 2. And then, so I get negative 2 times the square root of 25 is 5, square root of 2, minus square root of 100 is 10, square root of 2, plus 5 times the square root of 36 is 6, square root of 2. So then I get, oops, sorry. All right, so negative 2, from the square root of 5 is 5, square root of 100 is 10, square root of 2, and then plus 5, and the square root of 36 is 6, square root of 2. Now simplified, negative 2 times 5 is negative 10, so I get negative 10 square root of 2, minus 10 square root of 2, plus, and then 5 times 6 is 30, square root of 2. Now all these are like terms because they both have square roots, and the radicands are the same. They all have radicand 2. So a negative 10 and so all you're basically doing is just adding their coefficients. A negative 10 and a negative 10 is a negative 20. A negative 20 and a positive 30 is a positive 10. So the answer is going to be 10 square root of 2. That's number 5. Let's do one more with this, and then we're going to look at problems where you have variables instead. All right, so number 5. You have, let's say, the square root of 75 minus 2 square root of 300 plus 6 square root of let's say 72 plus 2 square root of 162. Alright, so square root of 75 minus 2 square root of 300 plus 6 square root of 72 plus 2 square root of 162. Alright, square root of 75, I know that 25 goes into 75, so I can write this as 25 times 3. Minus 2 square root of, I know that 100 goes into 300, so it'll be 100 times 3. Plus 6, and then 36 goes into 72, so it'll be 36 times 2. Plus 2 times the square root. Now 162, let's see if 4 goes into this. So that's a big number, so you may want to do this idea here. So let's see, 162 divided by, alright, so let's try 16. 162 divided by 16. So 16 will not go into 162. I get a decimal. So the next perfect square would be 25, but 25 won't go into this. We know, we can tell 25 won't go into this because the last 2 digits are not divisible by 25. 36, let's try 36. 162 divided by 36. Again, that's a decimal. Keep going. 49. 162 divided by 49. Keep going. 8 squared would be 64, so 162 divided by 64 equals, okay. Next one, 9 squared is 81, 162 divided by 81 equals, okay, so that's the one that works, be 81 times 2. So 81 times 2. Alright, so, so this becomes, square root of 25 is 5, so that's 5 square root of 3. Minus 2 times the square root of 100 is 10 square root of 3. Plus 6 times square root of 36 is 6 square root of 2. Plus 2 times square root of 81 is 9. And you get square root of 2. So that's 5 square root of 3. Minus, that's 20 square root of 3. Plus 36 square root of 2. Plus 18 square root of 2. Combining like terms, these two I can combine because they both have square root of 3's. So 5 square root of 3 subtract 20 square root of 3. So 5 subtract 20 is a negative 15. So you have negative 15 square root of 3. Over here, these you can combine because they both have square root of 2's. So 36 plus 18. So 36 plus 20, if that was 20, that would be 56. Okay, but I need 18, so it'll be 54. So plus 54 square root of 2. Okay, now these two you can't combine because this has square root of 3, this has square root of 2, so you're done. That's the answer. Now if you want to write the term that involves square root of 2 first, you can. It'll be 454 square root of 2 minus 15 square root of 3. It does not matter which one. Okay, so now, okay, so that's going to take care of part 1 that just involves, now notice part 1 though, there weren't any variables involved at all. It was just numbers, just real numbers. Okay, so that'll be part